Hello guys, welcome you all for this end-to-end session of AIML, DL, computer vision, NLP, Gen AI, everything. Like it's a full package of data science, a year-long program in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot. We are learning a lot each and every day. So hope the same thing for you guys. So before coming to the session, as always, please make sure you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay. And one more thing, sir mentioning each and every session, like please make sure you guys go to our YouTube channel and start attending the quizzes. There are 2000 plus quizzes available. Please make sure just attend the quizzes. It can be right or wrong, that is not a problem, just go and attend. Okay. And one more thing, please make sure you guys subscribe to our channel, because like every day just we are just posting a new video. Okay. So whenever we post a new video, if you guys have subscribed, so that you guys can get the notification, right? So please subscribe and press the notification icon so that you can get the periodical update from our YouTube channel. Okay. Yeah. So without wasting any time, let us jump into today's session. Today's session is a continuation of previous session, that is RNN, recurrent neural network. Guys, we have completed playing with data, we have completed machine learning, we have completed a basic structures of deep learning. We have moved on to something called as RNN, that is recurrent neural network, which is like we are having a buzzword called as chat GPT, right? It is a base. RNN is a very base. Okay, that is a base for chat GPT. Guys, just understand these words. Okay, can you guys able to understand? This RNN is a base for ChatGPT. Please make sure you guys understand this concepts. There's a black box behind the ChatGPT. Okay, let us understand this. Okay, so guys, please watch previous session. Previous session is what we have introduced you RNN. What is the structure of RNN? How RNN is built? What is unique in RNN? Okay, those things. Okay, let's understand today's concept. Vanishing and exploding gradient problems. Okay, vanishing gradients become very small as they propagate back through time, hearing learning in long sequence. Exploding gradients can become very large, causing instability and divergence during training. Solution: techniques like LSTM, that is long short-term memory, and gated recurrent units, that is GRU, address these problems by incorporating gating system or mechanism. Okay, guys, this RNN. Okay, I will just explore. I will just say again what is RNN. It is simple as machine learning on deep learning algorithm, but like only one flavor it is that it has, that is temporal data handling, that is it handles the time series data, time. Okay, it has a flavor of time. So due to which there are two problems occurs here: vanishing gradient. If the data or the sequence gets smaller and smaller, vanishing gradient occurs, so it will not able to understand the long sequence. Exploding gradient, if the sequence becomes larger and larger, it is not able to train and it will not able to diverge. Okay, those two are the problems. In order to get it over, we are having something called as LSTM and GRE, which are one kind of RNN, which can able to avoid these problems of vanishing gradient and exploding gradient. Okay, LSTM and GRE are something which is built on top of RNN in order to avoid these two problems. Okay, so yeah, sir, over to you.
Yeah, guys. So if you have come to this session, guys, go and watch all the previous sessions with long-term objective function and have patience, persistency, consistency, and perseverance. All this architect of learning will help you to build long-term objective function, and you will be always consistent and keep learning deeply. Now we are going deep into deep learning, depth for search. We have already done breadth for search earlier. So vanishing and exploding gradient problem. So vanishing gradients can become very small as they propagate back through time. Okay, okay, and they can learn the long sequences. Okay, okay, so this is what vanishing gradients are, that it is actually they help us in back propagation. Back propagation is like uh, propagating back through the time. That's why it is called. Okay, so propagating back through the time, and then we have exploding gradients. So gradients can become very large. Exploding means something becoming big, exploding. Okay, there was something was small and it is exploded and became big, right? So causing instability and errors during the training. So that is what is exploding gradient. And solution techniques like long short-term memory, LSTM, and gated recurrent unit GRU address these problems by incorporating uh, gating mechanism. So these are the three elements. Okay, let's go deeply to the other section.
Yeah, sure, sir. Okay, let's move on. Okay. Okay, let us understand. Okay, practical consideration for this RNN implementation. Let us understand. This is a time where we need to understand this because next session we're going to see the coding part of RNN. Right. Before that, let us understand what are the practical consideration that we need to do before going for this RNN implementation. Data pre-processing, properly preparing the data, including cleaning, normalization, and tokenization, is crucial for successful RNN training. Not only RNN training, all kind of algorithm need a proper data pre-processing. That's the reason we have took you to nearly 1.5 months of training the data. Like not like training, not it's completely pre-processing. Everything related to ED and VDA we have done for nearly 1.5 months. Okay, that is what the first thing. Hyperparameter tuning, optimizing hyperparameters such as learning rate, hidden size, hidden layer size, activation function, and can significantly impact the performance. Not only for RNN, all kind of algorithms has their own hyperparameters. For example, we have learned about decision tree, right? Okay, let us put it in this manner. We have learned about random forest, where it is a combination of different decision tree. We need to specify how many decision tree we need in the random forest. By tweaking that value, we can make the random forest model's accuracy more. Okay, that is what the hyperparameter for random forest. Similarly, for RNN, there are multiple hyperparameters available. For example, learning rate, hidden layer size, activation function, multiple things, man. Okay, that's why you guys need to tweak this hyperparameter so that you can get the maximum accuracy. I'm saying right. So optimal accuracy. Okay. Now, moving on, we are having something called as a computational resources. RNN can be computationally demanding, requiring significant memory and processing power. That's true, right? Because RNN gonna work in a manner where it gonna see the previous state and also current state and it gonna throw the output, right? That's the reason it's gonna take more computational time and also power, energy, resources, everything, right? So that's why we require this computational resource. So this is all the some of the practical consideration for RLM. Okay. So yeah, sir, over to you.
Yes, so practical consideration for RNN implementation is data pre-processing, properly preparing the data, including cleaning, normalization, tokenization, is crucial for successful RN training, guys. So pre-processing, we've been reiterating, I think, more than 50 times that pre-processing is very, very important, and it is same important for implementation, like practical consideration for RNN implementation. Data pre-processing is very, very crucial, guys. Each step is very crucial, but data pre-processing is very important. Okay. Second is hyperparameter tuning. So it is for So hyperparameter tuning is optimizing the hyperparameters such as the learning rate, hidden layer size, activation function can significantly impact the performance. So performance optimization, we need hyperparameter tuning for performance optimization. Simple. Computational resources, RNN can be computationally demanding, requiring significant memory, okay, computational resources, like you need GPUs, okay, all the computational things, you need compute power, okay, that's very, very important, okay, for implementation hour, because they are like, you have millions of data, billions of data sets, okay, for processing and making such models and creating world-class models, okay. Anybody can create models, guys. everybody, I think these days people are creating models, this and that. But creating a disruptive model which really solves the practical problems and considers ethical considerations and brings a new kind of wave, that is a real model, guys. For that, you need these parameters, these implementation, considering all these. So really you need to do great training on a clean and ethical data as per the problem statement, what really you're solving the problem which is creating win-win in the world, and that will create a disruption and change in the world revolution. Okay, keep learning deeply, guys, with long-term objective function, patience, persistency, consistency, and perseverance. With this learning architect, absorb the information, digest and apply the information, do all the quizzes and apply the concepts deeply. Okay, with long-term objective function of your career. Let's learn the other session.
Yes, sir. Let's move on. Okay, guys, let's have something. Yeah, okay. Down. We are going for advantage and disadvantage, guys. Now we have understand what is RNN, what are the things that is, what is the structure, how to do it, what are the consideration, like practical consideration or for that for implementation. Now we're gonna see what are the advantages and disadvantages of RNN. What is the advantage? It can handle the sequential data. True, that is very very true. Capturing temporal dependency, that's a major concept of RNN. Versatile applications, yeah, because it has something which is not have not able to done by any of the model, right? So it has versatile application. What are the disadvantage? We have seen, right? Vanishing exploding gradient, which can be handled by LSTM and GRU, but that is one of the disadvantages of RNN. Computationally complex, sir is explaining, right? There are going to be millions and trillions of data, so it's going to be computationally expensive because it need to follow the sequence also. Difficult in long-term dependency, because if it go for a long term we will be hitting with, I think, like exploding gradient or vanishing gradient, any kind of factors. So these are the advantages and disadvantages of RNN. Yes sir, over to you.
Yeah, advantages and disadvantages of RNN. Advantages are handling sequential data, capturing temporal dependencies, sorry, capturing temporal dependencies, okay, and versatile applications. So these are the advantages. Disadvantages are vanishing, exploding gradients, like back propagation, like back, it will go backwards, okay, and all. And computationally complexity, like computationally it is very, you need high compute power, and difficult to, like difficulty in long term dependencies. So these are advantages and disadvantages of RNN. And let's go to the other section. Keep learning deeply, deep learning with us.
Yeah, sure sir. So these are the advantages and disadvantages of RNN. Let's move on to the next slide. Okay. Yeah. So conclusion and future. Okay, conclusion. The future of RNNs in data science. What's the future, guys? We are in the present, right? But we are having ChatGPT, which is the future of RNN, but it is a present of RNN, right? So which is built on top of RNN. Okay, that's sequential character and temporal data understanding, all comes from derived from this RNN. Okay, yeah. First is speech recognition. RNN are expected to further improve speech recognition accuracy and robustness, enabling more natural interaction with the emissions. Today, we are having bots, AI bots, right, which can speak as human speaks. It can clone our voices, right, as I speak. Okay, as Sir speak, the bot can also speak because we are cloning the AI with a kind of tones and pitches that we are having. Okay, so today it is happening. It is not a future. Okay, now moving on, language translation RNN or poised to revolutionize machine translation, enabling more fluent and accurate translation across languages. Yeah, translation today, like I think all the languages can be translated, right? Because like Google, we are having multiple translators we are having, okay, which achieves this. This is presently occurring. Robots, okay. RNNs can be used to develop intelligent robots capable of understanding and responding to a complex environments too, because RNN has kind of a memory, right? So it can be applied apart to a robot so that it can have a memory, so that it can handle a sequence of things in sequential manner. Okay, hope you guys are able to understand, because guys, this is not a things of future. Presently we are having everything ready. Okay, more than that are happening. Okay, but try to understand, this is a way where we have achieved this one. Whatever things that we are having in the present, which is achieved through these kind of black boxes. Okay, just try to understand that. Okay, yes sir, over to you.
Yes, so conclusion, the future of RNNs in data science and AIML. So speech recognition, it is expected further improvements in speech recognition accuracy, robustness, enabling more natural interaction with machines. Okay, then we have language translation. So you RNNs can are poised to revolutionize the machine translation, enabling more fluent and accurate translations across languages. You can see like Siri, you have other like Alexa. You can see how they are like really working there. Like you will see Alexa it creating a new kind of wave once, because everything will be connected. Right now it is connected, it will be connected like when IoT will be there. So these things are going to really, like, you give commands and it is going to control your house. If your house, you are living in America, your house is in India, anywhere in the world, you can control each thing. And at that point of time, houses also will be very, very smart. Like everything will be like, you will have robotic houses actually, I'll tell you, because you will control your house through a mobile phone and app, through IoT with high speed. Like at that point in time we'll have very high speed internet, because you need very high speed internet. So all these things will be improving continuously. Robotics, RNNs can be used to develop intelligent robots capable of understanding and responding to complex environments. So these are the important aspects. Okay, RNNs can be applied and they are continuously improving, and research is going on and improvement is happening. Each month you are hearing new news, new article, new disruption coming in this field. Keep learning deeply with long-term objective function, patience, persistency, consistency, and perseverance, and a great vision of your learning, guys. Now if you want to compete with machines, AI, or deep learning, you have to have a great vision for your learning, irrespective of how much you are earning. Continuous learning is the only solution, and deep uh, aspiration for learning. Okay, deeply learn, uh, deeper than the machines learn. Okay, that is what is the solution. Okay, keep learning deeply. Let's see you in the other section.
Yeah guys, so this is all about the theory and black box behind RNN. Okay, next session we're gonna see the coding part of RNN. I'm very much interested to just showcase you what is the coding, what is the flavor of coding that we're gonna have for RNN. Okay, so that's all about today's session, guys. We will all meet in the next session. Until next session, bye guys, take care.